Good evening, everyone. My name is Irene Meier, and it is my pleasure to introduce you to the third and last session of today's webinar. And we're starting with Victoria Brugada-Ramentol on the intersection of neuroscience and virtual reality. She's representing VirtuaLeap today. The stage is yours.
Thank you very much. So let me just share my screen very quickly. So thank you very much for the nice introduction. I'm very happy to be here today. I'm going to be presenting to you Enhanced VR, which is a cognitive training solution that stands at the intersection between neuroscience and virtual reality. A little bit of background. I'm a neuroscientist at VirtuaLeap. I started by doing my PhD at the Champalimaud Foundation using virtual reality on the role of the importance of visual motor information for embodiment and self-representation, which ties very nicely what I'm currently doing now at VirtuaLeap. VirtuaLeap is a health and education startup based in Lisbon, Portugal, that leverages the full potential of VR to create cognitive training and monitoring solutions, which are enhanced VR, and that aims to improve cognitive functioning in both healthy participants, but also in elderly and in patients. On top of that, I'm part of the wonderful group that's the Brain Fit for Life organization as a young advocate. So as you can see, I spend a lot of my time thinking on brains and how to keep cognitive functions healthy. And that's because cognitive functioning, it's not stable throughout our lifetime. It does change, it increases as we grow old, peaking around young adulthood, and slowly some of the functions start to decline as we age. And this is true for healthy aging, but also as part of, and more pronounced in those suffering from neurodegenerative diseases such as Alzheimer's. And as we all know, the amount of elderly population is growing with a projected 1.6 billion in the next 30 years. So it becomes imperative to find solutions that help slow down this decrease. And as you've been hearing throughout this symposium, healthy eating and maintaining a healthy lifestyle, such as engaging in physical activities, do play an important role, but also engaging in cognitive stimulating tools, have been shown to be able to delay the onset of dementia and also help maintain healthy cognitive functioning. But also cognitive training tools that provide a structured training and stimulation of specific or global cognitive functioning can also play a role in this part. Specifically, screen-based cognitive training systems have shown improvement in the trained cognitive abilities, but these systems do have a caveat, which is the fact that, as you can see here, they are 2D, the interaction with them is through the hands, and this could, it could be a reason why they do not show transferability to activities of daily living due to poor ecological validity these systems may present. But on the other hand, VR systems do offer a multisensory experience, an embodied experience of an environment that at the same time engages the whole body and tracks it, but also provides a wide range of behavioral data. Virtual reality has been around for some time. At the beginning, it required a lot of technology, and they may occupy a lot of space, such as the cave systems that were 4 walls with projections that reacted to the participants' movement. And but nowadays these systems they were very big. So who has the space in their living room to have these systems if they want to use VR? Happily, recent advancements in technology allow us to have these head-mounted displays that are lightweight and comfortable to use, which makes cognitive training solutions in VR every time more accessible to the population. And while screen-based systems may have failed to provide transferability to global cognitive functioning or to transferability to activities of daily living, VR, due to its inherent characteristics, may provide this transferability to these activities of daily living. And that because it has these very nice features, such as VR systems now allow us to interact with the environment in a more naturalistic manner by doing actions that we may do in our daily days. These actions also give the user proprioceptive and motor-related information, which in times helps provide a higher sense of immersiveness and presence in the environment, which can in turn increase engagement and adherence to the training. On top of that, virtual reality systems allow to have a very precise control over the objects that are shown to the participant, and therefore we could provide activities that are more similar to activities that we may encounter in our daily life. And with all of this in mind, VirtuaLeap has created Enhanced VR, which is a library of cognitive training exercises that can be accessed through a head-mounted display. Enhanced activities range across 7 cognitive categories, which are memory, attention, information processing, motor, problem solving, spatial orientation, and flexibility, being spatial orientation and motor control, unique features to VR. Currently, the library offers 14 games, but we are always developing more and increasing the size of the library, and these games are divided across these categories. Each of these games is motivated and inspired by already existing neuropsychological principles, such as the Stroop task or the NBAC. And to illustrate how we create each one of these games, I'm going to focus only on one, which is Orbital, which is one of our latest spatial orientation games. Orbital is inspired by the mental rotation task. If you're not familiar with the task, very quickly let me explain. So this task, the user is shown a target image which is the one on the left, and a couple of stimulus that are the ones on the right. The stimulus might be either just a rotated image of the target image or a mirrored and rotated, which makes it different. So the task requires the user to mentally rotate and then select which is the image that actually is the corresponding image to the one. As you can see, this is not very naturalistic that we can find in our daily environment, as it's a 2D representation of a 3D image, and the task that the action is simply pointing at which one of the images it is. So when we want to transform this into one of our gamified experiences while maintaining the mechanics of the test, what we do is first, the science team enters in place and does a wide literature research on the task and defines 4 characteristics, which are the actions that are required to perform the task, the stimulus that can be presented to the user, in which ways this task can have a progression as to make it more difficult and increase the difficulty levels, and also which measures, apart from accuracy, we can extract from this task. After this is done, the whole team enters in play, including the science that will be also during the whole process to make sure that the mechanics of the test are maintained. And then we have the game designers, the programmers, the artists, and the quality assessment team to deliver what would be the final game, which is Orbital. In Orbital, we engage the mental rotations abilities of the user by having them direct a spaceship towards the planet that you see on the center by guiding it through rotating a sphere. The mental rotations abilities are ensured by limiting the number of steps that they can do, so they cannot just make any step. They have to actually check which road to take and then commit to one of these steps. And this process is what we do for each of the 14 games that we currently have and the new ones that are upcoming. Another very interesting feature of VR is the wide range of data that we can collect. We can collect this, how well they perform in the task, which we can call the cognitive scores, but also a wide range of behavioral data. And since Enhanced is designed to be played regularly, this data will then be longitudinal. So every time that the user logs into the app, which is designed to be played daily, they will get their workout of the day, which is a selection of 3 games from the library, which will change every day. Once they finish, they will get the game scores for each of the games, which can be used to compute the category scores. Both the game scores and the category scores can be tracked longitudinally through our app and also compared to the global performance of the user. So for example, you can see that this mock user here is performing better in memory than the average, but it's right on the average in the problem solving and the processing categories. The category scores will be aggregated into the EPI, which is the Enhanced Performance Index, which will be the fastest way to track the performance of the users across time. Apart from this data, we also log a lot of behavioral data in the shape of the moments. Moments are game-specific events that will then allow us to take more information on how the user is performing. For example, we can use the moments once we process them, to measure the reaction times of the user. Which hand are they using? Are they showing a preference for either performing the task with the left or the right? how accurate are they on their performance, but it also allows us to be able to offline reproduce the game of the users and see exactly how they performed. I'm going to show you now a very quick example on that, which is using one of our games, which is Memory Wall. In Memory Wall, the users are shown a grid that will light up in the shape of a pattern, and they have to memorize this pattern and later reproduce it. I'm going to show you two levels, so level 4 and level 6 for the same user. In level 4, as you can see in blue, they are required to do this pattern shown in blue, and they respond correctly to all of them. Then in blue again, I'm showing the pattern in level 6, and as you can see, they are missing the squares by 2, which shows that this type of data will allow us to then compute if not only if they perform that specific session correctly or not, but also which type of mistakes they performed, how far away they were from their targets, and so on. Apart from this behavioral data, we also do track postural data from the headset and the controllers. And each time that the user logs into the app, they are required to point in a 5-point Likert scale the amount of hours slept and how are they feeling on that day. So using all of these data, we hope to be able to test 3 research aims. One of them is first, as we were mentioning at the beginning of this presentation, that VR offers a new scenario for cognitive training, and that this scenario could potentially improve transferability of skills. And so that's one of the things we would like to test, whether daily training using enhanced VR and due to the characteristics of VR can improve global cognitive functioning and transfer to activities of daily living. Also, together with machine learning algorithms, we would like to leverage all of the data that we have into being able to create patterns of cognitive decline that come from these longitudinal data. And once these patterns are identified, they could act as digital biomarkers of cognitive decline. And lastly, to be able to validate our tool as a cognitive monitoring tool in the cognitively diverse population. But of course, we do not run our research in-house. We establish partnerships to be able to run all of this. So I would like you, before finishing, even though I'm running out of time, very quickly, 2 examples of this type of partnerships. First of all, very recently, we ran a workshop with our neighborhood where VirtuaLeap is set up, on which we tested our app in a group of 55-plus-year-old participants, and to gather some feedback, and they found it enjoyable and easy to use. And you can see here some experiences of our team showing them how to play some of our games, and accompanied by our robot Pico. But also, together with our partners in Italy, we have run a study, and I would like to share with you the post-experience questionnaires, in which they show that in a group of elderly populations of 41 of them, we found that participants felt that the experience felt as a real experience, and they felt they were interacting as they would interact with their real life scenarios. But also, interestingly, it was funny to see how all of them mostly realized that this could be VR could potentially act as a diagnostic and therapeutic tool. With that, I would like to very quickly end by presenting you the team at VirtuaLeap, who makes Enhance possible. And I'll be happy to answer some questions in the Q&A or later. And please feel free to drop us a line if you have any further questions. Thank you very much.
Thank you so much, Victoria, and fascinating. Unless any other questions show up, let me ask the first one. So the games that you showed us are mostly cognitive games, or also like things that people can do, like maybe sitting with their hands. Do you have anything on stability and maybe gait, or is that not possible with virtual reality just because it would be too dangerous for people to walk with the tool?
So thank you so much for the question. That's actually very interesting because I was not able to address this. Actually, so gait, of course, makes it difficult because it requires the participants to move, and then it increases the chances, for sure, at least, of them suffering from cyber sickness, and then makes the experience uncomfortable. That's why we design our games for them to be static or even to be played seated down. But yeah, so that's why I think that's one of the questions you answered. On the other hand, I think you were talking about stability. I'm guessing you mean postural stability. We do one of our games, actually, not for postural stability, but aims to target balance, so that they have to make sure that they can contain some spherical objects by maintaining two on plates. So it's not about actually their postural stability, but we can target this type of task in which they have to motor control objects in their hands and maintain them in balance.
Brilliant. Thank you so much. And I'm sure we'll have more questions later on. Oh, we have another one. What about virtual exercise?
I mean, like, sorry, I don't think I'm getting the question, Camila. I'm going to assume it's exercises, going to the gym, or some in this sense. Of course, in other tools it would work, but we do target our tool very much to engage different cognitive functions, but at the same time that we are using motor control. But for sure, it would be possible to do strength-related exercises or body flexibility-related exercises. But that's on another scope than on our app.
Thank you so much, Victoria, and I'll see you shortly again.